So I just wanted to review with you what happened in the lab yesterday and what we talked about in class today. You can tell from my activity that my data table looks a little different. I had to move the physical versus chemical change. It's all the way on the other side, or open or closed system. It's all the way on the other side, but all the data is still the same, okay? So in part one of the lab, I had a piece of steel wool that I took the mass of, and then while it was still over the balance, I pulled that steel wool apart. I didn't lose any pieces. I just kind of made it fluffier. And then I weighed it again and I saw my mass did not change. So my change in mass, which I would take the final mass minus the initial mass, is 0. So I conserved my mass here. And when I drew my particle pictures, I represented conserving my mass by drawing the same amount of particles, just looking a little different. So before I had 7 particles, after I had 7 particles, they were just spread out more. This was an open system, and this is only a physical change, okay? In part 2, I took an ice cube, I put it in a beaker with a watch glass on it. I weighed that whole thing. It was 81.22 grams. I let it sit for 10-15 minutes until all the ice melted. I weighed that whole thing again, the beaker with the top on it, with the water now in it. I saw that the mass did not change, okay? I represented that by showing you that my ice cube was made of 6 particles and my water is made of 6 particles. So my mass did not change. I conserved it. This was a closed system because the top is on it. And this is only a physical change. It's still water. One was solid and then it changed to a liquid water. Number 3, I made this goofy looking barbell thing that I filled one side of the pipette with liquid A, one side of the pipette with liquid B, and I very carefully masked them, staying on their own sides, okay? And I got 2.81 grams. Then I picked up my little contraption, my little barbell of pipettes, and I shook it together, and a chemical reaction happened. Okay, I know that because it turned cloudy, so that's a color change. Okay, and I weighed it again, and I noticed that my mass did not change. So I conserved my mass, and I showed that by showing 6 total particles, okay, 3 dark, 3 light. In the after picture, to represent that a chemical change happened, I made compounds. So a dark one combined with a light one, but still 6 total particles. So I'm representing that I conserved my mass. I just changed its form. So I combined them. This was an example of a closed system and a chemical change. Number 4, I took that piece of steel wool from number 1 and I masked it. And then I heated it up. And when I heated it up, the heat from the flame caused the oxygen in the air around the piece of steel wool to bind or chemically combined with my steel wool. So we can't see the air around it. We can't get the mass of the air around it. But once that air is chemically combined with my steel wool in a process called oxidation, I noticed that the mass of my steel wool went up because I added oxygen particles to it. This is number 1, an open system. And number 2, I know it was a chemical change because it was kind of hard to see in the video, but there was a color change to it, okay? So the steel wool got a lot darker once I added the oxygen to it. In part 5 of the lab, I took a little vial with some water in it and I put it on my balance, and next to it on the cap, I put some sugar. And I took the mass, I got 21.54 grams. Then I very carefully poured the sugar into the vial and I put the cap on, shook it up a little bit, weighed it again as one big thing, and I got 21.54 grams. So my mass did not change. I represented that by starting with 8 particles, 5 water, and 3 cubes of sugar that I drew. And then you can see in the after picture, I still have 5 circles representing the water and 3 squares representing the sugar. They're just all mixed together. It's a closed system, and it's also a physical change because if I really wanted to, I could get back the sugar and water and separate them. The coolest one was the last one. So I took some Alka-Seltzer, which is a type of medicine that you mix with water and you drink it. And what I did was I filled a water bottle with a little bit of water. I put it on my balance. And then next to it on the cap of the water bottle, I put the Alka-Seltzer. And I got the mass of that entire thing. And it was 77.97 grams. Okay. I then put the Alka-Seltzer in and I really quickly put the cap on. So I turned it into a closed system. And I watched as a chemical reaction happened when the Alka-Seltzer combined with the water, and I created a little bit of gas. You will notice that the shapes in the before and after are different, and here's why. Because I have the liquid circles, the triangle Alka-Seltzer, but I created a gas, so I represented that by squares. But if you look, I still have 8 particles before and after. Just some of them changed form to create a gas. But overall, I kept the same amount of matter. So there was no change in mass. Then I took that cap off and I noticed that my mass went down because now my gas particles are able to escape. So the only thing left in my water bottle is water and some pieces of the Alka-Seltzer. So that is now an open system and a physical change. I know that says chemical there, but this is actually a physical change.